As soon as we mount heat on this, the volume of this guy will increase. Why? If you still remember the kinetic theory of gas, you observe that the last theory, which is the fifth one, told you that that the kinetic energy of a gas is directly proportional to its average temperature, absolute temperature. Good day, my people. Once again, we are going to be looking at this topic in chemistry called gas laws, right? Okay, let me introduce this to you or to us. Before now, we've treated matters and states of matters, right? In which we treated the solid states, the liquid states, and the gaseous states. But do you know that after all these states, there is no other state that has a law or laws guiding it, right? But only the gas or gaseous states has law guiding it. Now, this is the reason. The reason we are treating gas law is because among the three states of matter, gases are the only states, or gas is the only state, or gaseous state is the only state that behave in a unique way. Am I communicating? Am I communicating? Yeah. So they behave in a unique way, just like when we treated elements, okay? And after treating elements, we now started, running a branch of chemistry from just one element known as carbon, isn't it? In carbon, carbon is the only element that made us to have what we call organic chemistry, which is another unique or another separate branch of chemistry. All we are doing for now is in inorganic chemistry. We're not doing anything concerning organic chemistry, right? So, but carbon is behave in a unique way that makes us to divide or extract carbon as a branch of chemistry. Am I communicating? So we are going to be looking at this outline. Number one is the introduction, which already we've started, isn't it? Yeah. Then number two is definition. So under definition, we are going to be looking at different definitions of different terminologies or different terms used in gas laws, right? Now, for those that doesn't know, to layman understanding, and for those that doesn't know anything concerning what do you call it, or laws rather, okay? Laws are the they are said to be the theories or the conclusions, okay, which is already proven theories or conclusions which is already tested or experimented using some apparatus or equipment. Am I communicating? In science, there is what we call scientific method, isn't it? That what we call scientific method. As a scientist, the only reason that differentiates you from any other discipline is your ability to observe. Then when you observe, there is something comes up with observation as a scientist, hypothesis or hypothesizing, right? So take for instance, if you look at the body, observe that I wrote down some things, right? I have some things being penned down. So as a scientist, you can be like, how did this marker be able to stick on this board? I get to my point. Immediately you observe this, something will come to your mind as a scientist. You might be like, okay, maybe it's because of this, because of the adhesive force between the marker and the board. Automatically, you have just hypothesized, isn't it? So hypothesis means below the main idea. Thesis means main idea. Hypo means below. Am I communicating? So why you call thesis, when a thesis or main idea becomes below, okay, is only if it has not been tested. Am I communicating? So if you're looking at gas laws, it means that all these laws we are going to be treating, of course, you have them on the board, are already tested and proven laws. in science. Am I communicating? And most of them are or were named after the person's what? Name. After the person that works on them. I get my point. Now, gases has physical properties and what? Chemical properties. Am I communicating? Now, in this topic, we are going to be looking at, the people or the laws that explains the what? The physical properties of gas, and also the law that explains what? The chemical properties of what? Of gas. Am I communicating? Am I communicating? Of course, the out of the all the laws we have in gases, okay? The main law that explains the chemical properties of gas is what we call the Gay-Lussac's what? Law. Am I communicating? Gay-Lussac's what? Law. Of course, in synchrony or in synchronization with what? With Avogadro's what? Law or principle. Am I communicating? So, I've been able to introduce what we are about to do, right? And as a matter of fact, I'm able to what? Define what? Gas laws. Am I communicating? So, if you don't understand, what are gas laws? Gas laws are those laws, theories, principles that is already tested and what? And proven. Am I communicating? Which studies the physical and the chemical properties of what? Of gas. Am I communicating? Yeah. So, now I want us to look at some terminologies because I feel that there are some persons here who are still a novice, right? And that what? In science as general. So we're going to be looking at some terminologies in gas law, okay, or in gas laws. The first terminology we're going to be looking at is what? Is the gas volume. Am I communicating? Is what? Gas volume. Make sure you're writing, right? Now, when you talk about volume, volume simply means the content of a substance or a material. Now, I'm using substance because I'm doing what? Chemistry. Now, if it's in physics, you hear us talking about what? Body and objects. Am I communicating? In chemistry, we use what? Substance. So, the content of what? Of substance is known as what? The volume of the substance. Are you with me? Are you with me? So, when you talk about gas volume, it entails, is all about, some places are not writing. One thing about writing is that, it's been said that the shortest pencil is better than what? The longest memory, isn't it? Yeah. As you write, it tends to create some kind of neurons, in your brain and get it stored as fast as what? When you're just listening. And of course, you have it as a reservoir to go back and have some reference, right? So make sure you're writing. So in gas volume, when we talk about gas volume, this is said to be the space gas occupies. It's just what the space gas what occupies. Are you with me? Are you with me? Yeah. So gas volume talks about what? Space occupies by a gas. Am I communicating? And in chemistry, fixed mass or the same mass, am I communicating? The same mass of all gases occupies the same volume. Am I communicating? All gases occupy the same volume as far as they are of equal what? Mass. Let me explain. Are you with me? Are you with me? Gases are light. They are the lightest states we have, right? And that's why, the intermolecular forces between them are said to be negligible. So they move freely, colliding with themselves and the walls of the container, right? And when you allow them, when you open them, they do what? They escape. Am I communicating? Now, hydrogen gas is a gas. Nitrogen gas is a gas. Oxygen gas is a gas. Am I communicating? Chlorine gas is a gas. Iodine gas is a gas, right? Now, all these gases will, have ability to occupy the same space, no matter the size. Am I communicating? Hydrogen gas is the lightest gas of the ones I just listed, and of course, of all gases. Am I communicating? But the same amount of volume or space hydrogen gas occupy, take for instance, 1 mole of hydrogen gas occupies maybe 22.4 dm3, which is what? A standard what? Gas volume. Am I communicating? Or call what? Molar gas volume. That's, by the way, I'll still get there. We are still introducing some things so that will be able to flow together. Am I communicating? Now, as far as is one molecule of what? Hydrogen gas, which is what? Something like this. This hydrogen gas, right? This oxygen gas, right? This chlorine gas, right? This nitrogen gas, right? You know, gases are what? Diatomic in nature, isn't it? So let's use these three, or these four rather. Now, hydrogen gas is lightest because the mass of this gas now is just what? 1 gram. Sorry, 2 gram now, right? Because I'm having 2 of them, isn't it? So 2 gram. But the mass of this guy is what? 16 times 2, right? 32 what? Gram per mole. Let me put it there. Per mole. It means that what? 1 molecule of what? Hydrogen gas occupies what? Sorry, weighs what? 2 gram. Am I communicating? Are you getting my point? Then this guy, 1 molecule of what? Oxygen gas weighs by mass on the what? On this spectrometer weighs what? 32 gram. Then this one, chlorine, right? So I have 35.5 times 2, right? So I should have it what? 71, if I'm not mistaken, right? This 71. 71 gram per mole. Are you with me? Are you with me? Because 35 plus 35 will give you what? 7 to read them, plus 0.5 plus 0.5, right? Which is what? 71. So it means that what? That the weight of this guy, this 1 mole, is bigger than this and this, isn't it? Then this one is what? Of course, 14 times 2, right? So I have what? 28 gram per mole. In case you don't know where we are getting all these things, you know, you have to go back and look for where we treat what's it called? The molar mass, or the mass numbers and the atomic numbers of what? Of elements. Am I communicating? Good. So, but all of us here knows the what? The weight of what? Of these gases. But what the gas volume, okay, where is it? Gas volume is trying to tell you is that what? All these gases will occupy a space. But as far as they are of the same mass, they have the same, you know, mass by mole. Am I communicating? What do I mean by that? This guy is what? 1 mole of what? Hydrogen gas. 1 mole of what? Oxygen gas. 1 mole of what? Chlorine gas. 1 mole of what? Nitrogen gas. As far as they have what? The same amount in mole, they are going to occupy the same amount of space in volume. Am I communicating? So this, and this will occupy what? 22.4 what? dm cube by what? Volume. Am I communicating? Are you with me? That's what you know about what? Gas volume. You know, think about it. When you come to solid and liquid, they are not like that, right? The volume of solid and the volume of liquid cannot behave like this. Are you getting my point? Because as far as the liquid is bigger by mass, it's going to occupy much more volume than the one that is what? Smaller. Am I communicating? But for gases, they don't do that. They behave in a unique way. Sometimes we call it abnormal in abnormal way, but it's not abnormal way. It's called what? Behaving different from normal. It's not really abnormal, but behaving what? Different from what? Normal. Are you with me? Are you with me? Okay, so the volume of a gas, of course, of any gas, okay, occupies what? 22.4 dm cube by what? By volume. Are you with me? Yes. And don't forget that 1 dm cube is equals to 1000 what? Cm cube. Are you with me? Are you with me? Good. And don't also forget that 1000 cm cube is equals to approximately what? 1 liter. Am I communicating? Is approximately what? 1 liter. Sometimes in exam they will give you, you know, dm cube in liter and you get confused. Maybe one parameter will be in liter, the other will be in what? In decimeter, or in what's it called? In centimeter cube, right? Isn't it? You can become confused. If you know this relation, automatically you can always be able to do what? To convert the order to align with what? With the first parameter. Am I communicating? Depending on your options. Are we together? Okay, let's go to temperature. Temperature. Now, we are looking at temperature now simply because if the temperature applied to a gas changes, am I communicating? The gas behave in a particular way. Let me explain that very well. Once you increase the temperature of a gas, are you getting my point? You know, some, not just some, the physical conditions or the physical properties of the gas will change. If you increase the temperature of a gas, are you getting my point? The volume and the pressure might be affected. Am I communicating? And that's why we are going to be looking at what? Temperature. But at this point in time, the temperature I want to look into is for me to tell you what temperature is all about. Are you getting my point? What the temperature is all about, and the units which are going to be using to be what? Solving questions under what? Gas laws, okay, as to temperature or temperature change. Are you with me? Now, what is temperature? This is said to be the what? The degree of hotness or coldness of a body. Are you with me? The degree of what? Hotness or what? Coldness of a body. The degree of hotness or coldness of a body. Of course, thermometer is used for measuring what? Temperature. Thermometer is used for what? Measuring what? Temperature. Are you with me? Are you with me? Good. Thermometer is used for measuring what? Temperature. So we use thermometer. Of course, meter means what? A device that measures what? Something, right? Then thermo means what? Thermal or heat. True or false? Good. Then another thing you need to note is that temperature can be calculated or measured using three different scales. It can be measured using what? Three different what? Scales, right? The degree Celsius scale, the degree Celsius scale, then the Fahrenheit, of course, degree Fahrenheit scale, then lastly, the Kelvin what? Scale. Are you with me? Are you with me? Good. And don't forget that 1 degree Celsius, sorry, 1 Kelvin, let's say 1 Kelvin, 1 degree Celsius is equals to 273 Kelvin. You know, you don't say degree Kelvin, right? You know, the man known as Lord Kelvin also worked on the absolute temperature, or what we call the absolute zero temperature, you know, and we were able to give him name, or give him a scale, okay, name a scale after his own name. Am I communicating? So I said I should note that what? Note that 1 degree Celsius is equals to what? 273 watts. 273 watts Kelvin. Let's say 1 degree Celsius. No. 0 degrees Celsius. Am I communicating? 0 degrees Celsius is equals to what? 273 what? Kelvin. Am I communicating? Am I communicating? Good. So let me go to pressure. Let me go to pressure. What is pressure? Pressure is said to be the ratio of force applied. The pressure of a gas is said to be the ratio of force applied on a gas to a cross-sectional area, of the gas, to the cross-sectional area of that gas. Am I communicating? Are you with me? Are you with me? Make sure you're writing, you know, as you learn, as you watch, you know, the video, you know, you pen something down so that it will be active and interactive, of course, communicative to you. Are you with me? So when you look at pressure, we say that what? Pressure is said to be the what? The ratio, pressure P is the ratio of what? Force all over what? Area. Isn't it? Now, when you say that you're exerting pressure on a material, you are using gas now, right? But let me use a material or any substance. If you begin to apply force on this area, that area you are applying the force, you are going to be receiving some kind of impact on that area, right? That impact that is being, you know, exerted on that particular part or area of the substance, okay, is known as what? Pressure. Are you getting my point? Which means mathematically that pressure is equal to what? Force all over what? Area. So we are going to have that the unit or pressure unit is what? Newton per what? Meter what? Squared. Isn't it? Because area is measured in what? Meter squared. Then force is measured in what? Newton. Am I communicating? Am I communicating? Now for gases now, okay? Now this is when you are looking at physical pressure. Are you with me? You are mounting pressure on a gas. Now, what about the inherent pressure that a gas has? Take for instance, the atmospheric gas has pressure or has atmospheric pressure. Are you with me? Are you with me? Are you with me? Now, the atmospheric pressure, you know, can be measured in different what? Units or scales. I get to my point. One is that we can measure the atmospheric pressure by in form of what? ATM. I get to my point. We can measure it in form of millimeter mercury. Are you with me? Of course, in Pascal as well, and of course in what? In Newton per meter what? Squared. I get to my point. Now, the atmospheric pressure is measured with a device known as what? Barometer, right? The atmospheric pressure is measured with a device known as what? Barometer. Barometer. What about the ordinary gas? I'm looking at, I just spoke about atmosphere. What about the ordinary gas? The ordinary gas pressure is measured in what? With what? Manometer. Am I communicating? Take for instance, you have a gas in a gas jar. If you want to measure the pressure of that gas, you use what? Manometer. But if you want to measure the pressure of the atmosphere in a particular location or region, you use what? Barometer. Am I communicating? So this guy is for what? Atmospheric pressure, right? Then this one is for what? Gas pressure. Are you with me? Yeah. Are you with me? Okay, and of course, the atmospheric pressure has a constant value. Am I communicating? And the constant value of atmospheric pressure is that 1 atmospheric pressure, 1 ATM, is equals to what? 760 millimeter what? Mercury. Am I communicating? Because the barometer you're seeing is being calibrated. It has a fluid. Am I communicating? In it, do you understand? Known as what? Mercury. Don't forget that mercury is the only what? Liquid metal. Are you with me? Are you with me? Then the device is calibrated in what? In millimeter. I get to my point. So as you add heat, as pressure is being mounted on the what's it called? On the barometer, right? On the device, the mercury expands. I get to my point. As it expands, it measures what? In millimeter what? Mercury. As it expands, it's measuring what? Millimeter what? Mercury. So that movement of what? Of the pressure fluid or pressure liquid or substance inside here, you know, as it moves up, it's moving along the what? The millimeter what? Calibrations, right? So any value that the pressure pushes the mercury up to will become the what? The value of what? Of that pressure at that moment of the gas. I get to my point. So, but the standard atmospheric pressure is that what? 1 ATM, which is 1 atmospheric pressure, measures what? 760 what? Millimeter what? Mercury. And I'll tell you why when you get to what? Standard temperature and what? Pressure. Are you with me? Are you with me? So, this over ATM also is also equals to what? 1.012 times 10 to the power what? 5 Newton per what? Meter what? Squared. I'm just using this one for this what? For this class, right? Isn't it? Am I communicating? Any question? Good. Now let's go to standard temperature and pressure. Standard temperature and pressure. Now in science, anytime you hear standard, standard means known. Standard means what? A known value. Are you with me? Standard means what? A known value. A known calculated what? Value. Are you with me? Now, what is standard temperature and pressure? This is the values of the temperature and the pressure. This is the value of what? Of the temperature and the pressure in which it's observed that at 273 Kelvin, let me use this guy. At 273 Kelvin, are you with me? The pressure of the atmosphere at 273 Kelvin, the pressure of the atmosphere measures 760 millimeter what? Mercury. So you can observe that you normally hear about room temperature, isn't it? Which means the temperature of this room, for instance, is known as the room temperature, right? Isn't it? But what we mean by that is this, we have a standard temperature in which every object that is not hot or cold should be. That is normal temperature. We call it what? Room temperature. I get to my point. As far as 2 or more persons are in a room and there is no too much ventilation, automatically the temperature might increase. Do you understand? Of course, that is still in the room. But room temperature is just what? The normal temperature a room that does not contain anything in it has. Are you with me? And there is mainly between what? 17 degrees Celsius to what? 25 degrees Celsius. Am I communicating? Particularly what? At what? 25 degrees what? Celsius. That is what? Room temperature. Am I communicating? So it's been measured that anytime the standard value of temperature, which is what? At 0 degrees Celsius or at what? 273 Kelvin, is being measured that what? That barometer will read that the pressure is what? Is 760 what? Millimeter what? Mercury. We now call it what? 1 atm. We call it what? 1 atm. Do you see it now? So automatically, for me to be able to calculate the temperature, the pressure of any gas, for instance, as far as I know the standard value for temperature and the pressure, right? For me to calculate the pressure of any gas, take for instance, if the pressure becomes, if the temperature becomes 450 Kelvin, for instance, right? If it becomes 450 Kelvin and someone is asking me, what is the pressure of the atmosphere? I don't need to waste my time. I don't need to get confused. All I need to do is to what? Is to say that what? That 273 Kelvin, isn't it? 273 Kelvin was able to give me what? 760 what? Millimeter what? Mercury. Do you get the point now? Then 450 Kelvin will give me what? X what? Millimeter what? Mercury. Then when you come and supply, you get the value of your what? Of your pressure at what? 450, because you know what? Standard value. Am I communicating? Because you know standard value, that's why you're able to what? Solve it. Do you see it now? Am I communicating? So at this point in time, we are going to be looking at what? Laws of what? Laws of what? Gas. Okay. Are you with me? Now let's go to gas laws, right? Three scientists studied the physical properties of a gas, of gases, right? Three scientists. Or maybe this way, three scientists studied the relationship amongst the what? The physical properties of gas. And the first scientist is an English scientist, an English physicist known as Robert Boyle. Known as who? Robert what? Boyle. Robert Boyle. Now, Robert Boyle studied the behavior, are you with me, of the volume of a gas. Robert Boyle studied what? The behavior of the volume of a gas with its pressure as far as the temperature is what? Is constant. Are you with me? He studied what? How the volume of a fixed mass of a gas will behave in respect to what? When the pressure is increased or decreased. Are you with me? As far as the temperature is what? Is steady. Are you with me? Are you with me? And after that relation, a law were made, okay? And that law we named after his name, and we call it what? Boyle's law. Are you with me? Are you with me? Then another person studied what? The relationship between the volume now and what? And the temperature. Another person studied what? The relationship between the volume and what? Temperature. As far as the pressure remains what? Constant. And that is a man known as what? Jacques Charles. Jacques. Are you with me? So Jacques Charles was able to study the relationship of what? Of the volume and what? And what? And temperature of a gas. Are you with me? And this is Jacques Charles. Jacques. Jacques Charles. So he was one that studied what? The relationship between the volume and the temperature of a gas. So he monitored what happens to the volume of a gas if the temperature is increased or decreased, as far as the pressure remains constant. Do you know why? There is no way, the volume of a gas will behave in ascending or in descending manner if the pressure or if one of these factors are not what kept constant. What are the factors? Temperature and what? Pressure. Because do you know why? It's already been observed that once the temperature of a gas increases, the pressure will also increase. Am I communicating? So once the pressure of a gas increases, the temperature will also what? Increase. Now let's use an example. Take for instance, if you blow yourself, right? You blow yourself on your skin. That is pressure. You're mounting pressure on your skin. And of course, then they're using gas now, right? So if you blow yourself, you'll find out that what? That the temperature of your skin increases because you've applied force on that particular area of your body. Are you with me? Are you with me? So for you to monitor how volume will react with pressure, you have to make what? Temperature constant. For you to monitor how volume of a gas will react with temperature, you have to what? Make what? Pressure what? Constant. So making it constant means that what? Pressure will not be what? Manifesting or affecting the what? The experiment or the system. Thank you. And if you make temperature constant and you're monitoring volume and pressure, it means that what? Temperature is not what? Is not affecting the what? The system. Are you with me? Are you with me? Of course, Lord Kelvin, studied on the scale known as what? Absolute temperature was scale. Are you with me? Yeah, which were later were abolished. Am I communicating? This law were abolished with what? With Charles' law. The Charles' law was the law that what? That we are using to solve calculations under the relationship between volume and what? And temperature. Am I communicating? I get to my point. When you talk about what is it called? Absolute zero. I will still talk about it just shortly. Are you with me? So let's look at Boyle's law first. Let's look at Boyle's law. Boyle's law. Boyle's law states that the volume of a fixed mass of a gas, Boyle's law states that the volume of a fixed mass of a gas is inversely proportional to its pressure at constant temperature. The volume of a fixed mass of a gas is what? Inversely proportional to its what? Pressure at constant what? Temperature. Are you with me? Are you with me? Good. So as far as the temperature of a gas remains constant, the volume of a gas will increase or decrease as what? As you decrease or increase the what? The pressure of the gas respectively. Am I communicating? Now, when you say inverse variation, what comes to your mind? It means that when I'm increasing the pressure, the volume of the gas will reduce. And when I reducing the pressure, the volume of gas will do what? Will increase. Am I communicating? So what that's supposed to mean? I have that what? That the volume or the fixed mass of a gas, right, is what? Inversely proportional to what? To the pressure, right? So this is what? Sign of what? Inverse proportional, right? So right now, we are going to, use this as our what? As a relation to find the formula for solving, the volume or pressure of a gas, right, at constant what? Temperature. So our constant here will be what? For temperature. Are you with me? So we're going to have that what? That V, we're going to remove this sign and introduce what? Equality and the what? And the constant, isn't it? And that would be what? K, right? Times what? 1 all over what? P. So you have that what? V is equal to what? K times 1 give me what? K all over what? P. Are you with me? So I'm going to make my constant solid for the formula, isn't it? Because I want to know the interaction between the volume and the pressure of a gas. If I know my interaction, whatever happens to the gas before I increase the volume or the pressure, am I communicating, will happen to any other gases. I get to my point. So I'm going to have that what? That K, which I made constant, is equals to what? V times P will give me what? PV. Of course, you don't say VP because you alphabetically have to say what? P before what? V, right? So K is equals to what? PV, isn't it? So at constant temperature, if I have pressure 1 of a gas at what? Volume 1 of that same gas, it is equals to what? Whatever pressure I have for what? For the second pressure, right? And what? Whatever that will happen to what? To the what? To the volume. Are you getting my point? So which means that if I multiply the pressure of a gas with the volume of a gas before I increase or decrease the pressure, am I communicating? It's going to give me equals to what? What happened to the what? Sorry, it's going to give me equals to what? The product of what? The final pressure and also what? What happened, the volume of what? The gas at that moment. Are you getting my point? Because if I increase the pressure here, automatically the volume here will decrease. Are you getting my point? That is the meaning. So P1 V1 is equal to what? P2 V2. So in exam, what happens? They will give you the pressure of the gas, maybe the initial pressure, give you the initial volume, and tell you that what? That this pressure will increase to what? A higher value. Am I communicating? And they will ask you what will be the volume of the what? Of the gas at final pressure. Are you getting my point? So you just have to say that what? Since your P1 V1 is equal to P2 V2, your V2 is equal to what? P1 V1 all over what? P2, isn't it? So multiply the what? The pressure, initial pressure with initial volume divided by what? By the final what? Pressure. Your value will be in what? In final what? Volume. How? Think about it. The value of this guy will be in what? Millimeter mercury. For instance, times what? Volume will be maybe in cm cube or dm cube depending, right? Go divided by what? This guy will be in what? Millimeter what? Mercury. So this divide this, your value will be in what? In volume, which is cm cube. Are we communicating? Am I communicating? So that is for Charles' law. So this is the formula we're going to be using for solving equations or questions under what? Boyle's law. Are you with me? So we studied what? Pressure and volume in Boyle's law, right? So let's go to Charles' law. Now I need to move ahead, even though there are some persons still right. Some persons are still writing, right? So for Charles' law, just like we said, Charles' law states that the volume of a fixed mass of a gas, Charles' law states that the volume of a fixed mass of a gas is directly proportional The volume of physical mass of a gas is directly proportional to temperature as far as pressure remains constant. Is directly proportional to what? To temperature as far as the pressure remains what? Constant. Now, before I go to this Charles law, let me give you something. Let me give you something here for Boyle's law. I'm going to use this to illustrate Boyle's law so that we understand it much more better, right? Now, if I have this as a container or a gas jar, right? Now, this gas jar is filled with some gases, right? Now, this gas, the way it is now, it doesn't have any pressure per se mounted upon it. It just has the normal pressure, right? Now, but because of the fact that I want to mount pressure on it, I want to attach something on top of this what? Of this gas. Am I communicating? Now, it's just like me covering it for it not to what? Escape, isn't it? Good. Because intermolecular forces are what? Are negligible, right? So, if I put a lid here, what's the lid? Cover, right? But this kind of cover is not the ordinary cover, rather what? A piston. I get to my point. Now, this is a piston. Why is it a piston? Because if I push this guy down, if I mount pressure on this lid, it's going to move on the inner wall, around the inner wall of the what? Of the gas jar. Am I communicating? So, but before I mount pressure on it, this gas has this amount of volume, V1. Are you with me? Are you with me? And it has a what? A particular amount of what? Pressure, what? P1. I've not mounted any pressure now, right? Now, immediately I mount pressure on it. Like, I exert force on it, right? You will find out that what the piston, this is piston, right? The piston or the lead. Now, the piston will start moving downward, right? Because I'm increasing the pressure. So, if I increase the pressure from here to here, are you with me? Automatically, every gases you're seeing here on top, all of them will do what? Will move down, right? They will not go out. They will move down. They'll be, because gases are what? Compressible, isn't it? So, they will just come here and get what? Compressed. Of course, this is another way you can liquefy your gas, isn't it? Because you mount pressure on it, it will do what? It will condense, right? When it condenses, it forms what? Liquid. Am I communicating? So, this is where the piston now is, right? This is piston now. So, at this point, what do? I increase the pressure, P2. Am I communicating? You will notice that something happened to the volume. The volume that was from here to here, right? V1 were decreased to what? To from here to here, V2. Am I communicating? So, as far as temperature remains constant, right? If you increase the pressure, the volume must what? Decrease. Are you with me? Are you with me? So, this is just what? The diagrammatic what? Illustration of what? Boyle's law, right? Now, can we continue? Yes. Any question? No, this is Boyle's law. I just explained Boyle's law. So, let's go to Charles' law. Now, Charles' law state that, I've said this, isn't it? Yes. Okay, mathematically, we have that. Mathematically, you have that the volume of a gas is directly proportional to what? To temperature, isn't it? At what? At constant pressure, isn't it? So V is equals to what? KT, as usual, isn't it? We replace this with what? With this, right? Isn't it? So V is equals to KT. So your K is equals to what? V all over what? T. So this is a relation we are going to be using for solving what? You're going to be using to be solving questions under gases when the temperature, okay, of the gas is increased or decreased. Am I communicating? So if this is a constant, it means that if V1 at T1 is given on a gas or about a gas automatically it must be equals to what? V2 over what? T2. Are you with me? So this is what? The formula we are going to be using for solving what? Questions under what? Charles law, or relationship between the volume and the temperature of what? Of gas at what? Constant pressure. Are you with me? Yeah. Are you with me? Yeah. Now let me give you some evidences to support what? Charles law. Let me give you some evidence to support Charles law. What do you think that happens to a balloon that is filled with air, like air-filled balloon? What do you think that happens to it if you add heat on it? Balloon, okay, that is filled with air, or air-filled balloon, then you start applying heat on it. What do you think that will happen to the what's it called? To the volume of the balloon? It will increase the volume. And that's why if the volume of the balloon, of the air increases, or the volume of the balloon rather increases, what do you think will happen to the balloon? It will burst. Am I communicating? I jumped something, right? A man as Amedio Avogadro studied the number of moles, studied the relationship between the number of moles of a gas, studied the relationship between number of moles of a gas with its volume. With its what? Volume. Are you with me? Are you with me? Now let me explain. This law states that, just write the law, okay? This law states that, Avogadro's law. This law states that all gases with the same mass, all gases with the same amount in mole, occupies a constant volume. Occupies a constant volume. As far as the temperature and the pressure remain constant. Or you can put as far as, you can put at standard temperature and pressure. Do you understand? All gases of equal mole, am I communicating? Occupies what? The same amount of what? Volume. Are you with me? At constant what? At standard what? Temperature and pressure. Yes, that is best way to explain this law. So it means that at STP, isn't it? We've done it already, right? At STP, what is it? This is it, right? Yeah, this is it. At STP, it means that 1 mole of every gas, am I communicating? Of every gas will contain what? Will occupy, rather, okay? Will occupy 22.4 dm cube by volume. Like I said, let me repeat. 1 mole put here of every gas occupies what? 22.4 dm cube what? By what? Volume. Am I communicating? And of course, this same law also told us that what? That 1 mole of every gas, I get to my point, contains the same number of particles. I get to my point. You see, contains what? The same number of particles. So this second theory now is what we use to explain the first what? Theory. You know, I told you that when you have hydrogen, oxygen, nitrogen, all of them does not have the same mass, right? But all of them will occupy the same volume. Reason being that what? 1 mole of any gas will contain what? The same amount of what? Particles. Am I communicating? Yeah, the number of particles will tell you what? How much volume that the gas will occupy. So if every gas, no matter the weight or the mass, okay, or is occupying the same number of particles, it means that they will occupy the same number of what? Volume. Are you with me? So 1 mole of every gas will do what? Will contain, are you with me? Contains what? 6.02, right? Times 10 raised to the power what? 23 what? Particles. Are you with me? Now these particles could be in form of what? Atoms, right? Are you with me? Ions or what? Molecules. Are you there? It could be in form of what? Atoms. It could be in form of what? Ions, or in form of what? Molecules. Do you get the point? Am I communicating? So when they ask you now to determine, you cannot count gas now. Like if I give you gas to count, you cannot count it, right? Now this is the value, the constant value given to what? To all gases. I get to my point. Now, if I ask you what is the number of atoms present in oxygen gas, in one molecule of oxygen gas, it means that what? As far as is one molecule of oxygen gas, it will contain what? This number of particles, right? Number of atoms. Because an atom is also a what? A particle. Are you with me? Good. If I ask you what is the number of ions present in 1 mole of oxygen gas, the same thing. If I ask you what's the number of what? Molecules present in 1 mole of oxygen gas, the same thing. Are you with me? Now, if I ask you what is the number of what? Atoms present in 2 moles of oxygen gas, what do you think? You do what? 2 times what? 6.02 times 10 to the power what? 20 what? 3. Am I communicating? Now, the same thing applies to what? Chlorine gas. Chlorine is what? Denser than what? Than oxygen, right? Isn't it? But as far as this law is concerned, that's what we call it what? Avogadro's what? Constant, or Avogadro's what? Law or number, right? So, as far as this law is constant, whether it's denser or of less dense, as far as talking about what? 1 mole of that gas, it will occupy the same amount of volume and contain the same amount of what? Particles. Are you with me? Are you with me? Are you with me? So it means that, for instance, if I have 1 mole of oxygen gas, will occupy what? The same value with what? 1 mole of what? Chlorine gas. The same value with what? 1 mole of what? Hydrogen what? Gas. Are you with me? That's what the law is talking about. I will call it what? Avogadro's what? Constant. Then due to the number, we call it what? Avogadro's what? Number. So when they ask you what's Avogadro's number, this number of what? Particles, okay? Present in what? In 1 mole of what? Any gas at what? Standard temperature and what? Pressure. So with this, we are done with what? Avogadro's what? Principle. So remaining the last one, right? From our outline, which is what? Ideal gas equation. Are you with me? Are you with me? Any question? Now, before I do ideal gas equation, I have to drop you a formula for solving or calculating or to represent the Avogadro's what? Principle or what? Constant. Am I communicating? Now, from your statement here, you observe or you believe with me that that at standard temperature and pressure, that the mass, that the mass of a gas is directly proportional to the number of moles. Am I communicating? The more you increase the number of moles, the more the volume will increase. The mass of every gas will what? Will increase. Am I communicating? Ideal gas equation. Now, when you say ideal gas equation, right? Now, when you say ideal gas are not real gas. Okay? Now, let's think about it. Let's think about it. Is there any way, hope you know that you have an equation which already driven, right? We drive an equation that said that that PV all over T1, right? We've read this equation, isn't it? Is there any gas that will be having increase in the pressure, then automatically the volume will be increasing and automatically the temperature will be decreasing at the same time? That is what the equation tell you now, that this is goes to constant, isn't it? Can a gas be increasing in pressure and the temperature will be decreasing? Is it possible? Is it possible? Not even that the volume is constant, the volume is active, working there. So the pressure was increasing, the volume was increasing, then the temperature will be going down. It's not possible. I get to my point. But from our derivative, we found that when we combine these two, Boyle's and Charles' law, we were able to form this kind of equation or this kind of relation, right? Now, this can only be exerted or experienced by what? By gas that exists in our head. I get to my point. No real gas will do that. That's what we call it what? Ideal gas. Am I communicating? Good. Now, let's relate it to what? To number of moles of the gases, right? let's relate it to what? Number of moles of what? Of the gases, right? Now, when you look at this, you observe that, you know, the volume of every gas, right, will have, is that proportional to what? To the number of moles from Avogadro's law, right? So, in forming ideal gas equation is a combination of Avogadro's law and the what? General gas what? Equation. Am I communicating? So, if I have this, it means that for Avogadro's, right? Avogadro's. So, if I have this, it means that my V is equals to what? Kn, right? And my K is equals to what? V all over N, isn't it? So, K here is equals to what? V. And the K here is equals to what? 1 over what? N, isn't it? Good. Then from general gas equation, we have that K is equals to what? PV all over what? T, isn't it? So if K is this, and this, I want to combine them. Are you getting my point? Now, if I should combine them, you know, this my K for that of Avogadro's law, I want to change it to what? To R. Are you getting my point? Yeah. Then I'm going to have R here, but it's still constant, isn't it? So R here, right? R here, isn't it? Isn't it? So I want to use R to denote what? The constant there. So it means that what? This R is equal to this K. Are you with me? So if K is equal to this, then I'm going to have that what? That K is equal to what? P times what? V, isn't it? Times what? 1 all over T times what? 1 all over N. Are you with me? Where this K is sent to me to what? R, because I'm using R now because of the fact that what? That I am dealing with what? With number of moles of the gas. Are you with me? But they are the same thing, isn't it? So I'm going to have that what? That my R is equal to what? P times V times 1 times 1 give me what? PV all over what? Tn, right? Then if I cross multiply here, I'm going to have that what? That P times V times 1, right? Will be equals to what? PV is equals to what? NR what? T. Are you with me? Where this your R, where R is known as what? Is known as what? Is known as what? The constants, right? Am I communicating? You call it what? The ideal constants. I get my point. So if you make R sort of the formula from here, we are going to have that R is equals to PV all over what? NT. Are you with me? So if you take number of moles of every gas as 1 and take the volume, the volume of every gas as what? You know, we are looking at standard temperature and pressure, right? So automatically 1 mole of every gas will occupy what? 22.4 dm cube by volume, right? Then they will measure what? 760 millimeter mercury. Am I communicating? Or 1 atm, and they will measure what? 273 Kelvin or 0 degree what? Kelvin. Am I communicating? But you're using Kelvin to calculate this, right? So if that is the case, I can find the value of my what? Constant. I get to my point, and I can't even remember. So let's find the value of the constant. So the value of the constant should be what? So I want to use ATM to calculate, okay, instead of 760. Are you with me? It's still the same thing. So how that's what? R is equals to pressure is what? 1 atm times what? 22.4 dm cube times what? Sorry, divided by what? 1 mole times what? 273 Kelvin. Do you get the point now? So I'm going to have what? 22.4 atm dm cube, right? All over what? 273 mole Kelvin. This is number of mole, right? Mole Kelvin, right? So I need a better marker, but that's by the way. Let's just finish it up. So what I have there? 0.08. 0.08 what? 82. Good. Which we got it correct. 2 what? So which means R has a unit, right? which is what? ATM dm cube per mole, right? Per what? Kelvin. So this is the what? The value is constant. So sometimes they will not give you that in what? In your calculations. They won't do that. Okay? They will just give you every other parameters, but they will not give you the what? The R, which is what? Constant. Am I communicating? They will not give you the R. So the R is a constant which you are meant to what? Know. But in case you forgot the way I just did, you can just what? Solve and get your what? The value of what? R. I get to my point and make what? Other parameters what? Standard. Are you with me? Are you with me? Any question? Any question? So with this, we have come to the end of this what? Topic, right? Isn't it? In our next class, we're going to be looking at what? Calculations under what? This topic, where we are going to be treating what? The stoichiometry or what? Mass volume relationship. Because after understanding this, you know, above Avogadro's and Gay-Lussac's, you need to what? Use it to what? To do stoichiometric what? Calculations. Are you with me? Yeah. At this point in time, we are going to call it what? Call it a day. Thank you for listening and God bless you.